Hello everyone, welcome back to MAT052. Hope you're having a good day. We're going to continue this time along the idea of confidence intervals and building those confidence intervals with inequalities and intervals. Okay, so let's get started. So operations in confidence intervals. The form of a confidence interval on the plus or minus side. So remember, let me kind of sketch over here what we're trying to do. Here's my general, if I can get my pen going, there we go. So what we want to do is that we have a population over here. We don't know what a particular thing is, and the ones that we're going to focus on in this lecture workshop is just the mean and the population standard deviation, whether we know this or not. So sorry, so population proportion. So we're not going to do this, we just use that. So we're going to build a sample over here, and if I'm concerned about mu, basically I'm going to use x bar, the average of this thing, as a point estimate. It's my first estimate that I've got for what the true mean of the population would be. Certainly not going to be equal. Maybe, but I wouldn't bet very much money on it. Okay, so what we're going to do is that we're going to develop, like on a number line, I'm going to have some numbers, and right in the middle of this thing I'm going to have, this is the generic picture, is the point estimate. So if I was doing the mean, this would be the x bar. And then I'm going to add x bar plus the margin of error, x bar minus the margin of error, right? So this combination right here can be built by just saying the plus or minus sign. So in general, x bar plus or minus the margin of error. And that's what the plus and minus sign is about. So all confidence intervals, all confidence intervals have the point estimate plus or minus the margin of error. That's the way they always start. So we're going to go in here, we're going to build a margin of error. We can just draw a generic picture on the number line. Here's plus infinity, out here is minus infinity, just like the old number lines that you're familiar with from grade school. And then we're just going to take the point estimate. What are we trying to estimate, and what looks similar to that in the sample? That's going to be our first estimate, and basically in the middle of this confidence interval we're going to develop, okay? And then it's always the point estimate plus or minus the margin of error, and this is different depending on what we're trying to do, okay? So this plus or minus sign indicates that there are two operations to perform. The first is the point estimate minus the margin of error if we're going left to right, and the second is the point estimate plus the margin of error, again left to right. I want to calculate this, the point estimate we know, and then we add that to it. Okay. So write an interval over here, write an interval equivalent to this statement. So I've got some point estimate here, and then I've got some plus or minus the margin of error. And that's kind of what we're going to come out with. Okay. So I'm going to start with the left to the right, the lower bound. So this is kind of what I usually draw out of my class. I've got my lower bound, my upper bound. My point estimate is in the middle. And what we're trying to estimate, the population parameter, can be anywhere in here because this is based on the sample only. Okay. So first of all, if I'm going to take my point estimate, I'm going to subtract the 13.8, that margin of error that's understood there, and I get a 53.6. And to get my upper bound, I'm going to add that margin of error. That'll give me the 81.2. And then I'm going to write this as an open interval. I'm not going to include these endpoints. Basically, if I wanted to write it as an open interval, just like in math, I would do the 53.6, the 81.2, and I do not include these numbers. If I wanted to include them, with the equal signs here, I would do a little bracket at the endpoints, but it's not. Okay, so that's strict inequality for the 53.6 and the 81.2. And if I drew a number line, naturally the 67.4 would be right in the middle of that. So we're just writing the notation now. We're not going to go through and do a statement about that. So consider the formula for constructing a confidence interval for a population mean where the standard deviation is not known. Okay, so if we know sigma is known, we're going to go x bar plus or minus. It's going to look just like this, but you remember we did z alpha over 2 and then the sigma over the square root of n. Here we knew what sigma was from the population. Possibly the mean had shifted, and we're just going to check it with build a confidence interval based on a sample, but we're going to use the standard deviation because we don't think that's changed. Okay, so that's how we did it. But now, what about if we don't know the standard deviation is not known? In many cases, this is the only one that's really you spend any time with in class, because this is more realistic for most situations. If you don't know the mean, you probably don't know the standard deviation. So here we're going to use this thing, and it's called a student's t-distribution. It is not the normal distribution to get the z, but this is a t. We'll kind of work on those as we need to and in class, but it's called the t alpha over 2, and that's the student's t distribution. And that would be table A.3 in the back of your book. Okay. So but just let's kind of go through and just build one based on some of the things that we would have already calculated. Okay, in a random sample of 100 US adults aged 18 to 24 who celebrate Halloween, the mean amount spent on a costume was $37.51. Sample of this, so this is X bar right there. That was the sample average. Okay, standard deviation, that's S. Okay, population would be that guy, right? That's the population. And based on a sample, we end up with an X bar and an S. Construct a 95% confidence interval for the mean amount spent on Halloween costumes for all US adults. The critical value is this, so they're going to give us that. We're not going to spend too much time going on the tables. We'll do that in regular class. Okay, so the solution, I go back to my formula. I know I'm building a confidence interval. It says to construct a 95% confidence interval. That number helps generate this thing. And with the student's t, I also need to know the sample size. But anyway, so we go here. We're going to build a confidence interval. So the confidence interval is x bar plus or minus t alpha over 2 times s over the square root of n. This tells me what I need to do. I need x bar, I need t alpha over 2, I need s, and a sample size. So here we list it all out. What is our x bar? That's our sample mean, 37.51. Our sample standard deviation, 16.44. That's from up here, right here. The sample size was 100, and the t alpha over 2, the critical value is 1.99. And again, that comes from the table. You have to kind of work backwards based on 95% confidence. Okay. So here we go. We're gonna construct this thing and round it to 2 decimal places. So here's our fundamental formula. Again, we always like to write that to let us know what path we're going down, what formula we're trying to work with. So now we just, the x bar, that's my 37.51, plus or minus, remember we're going to do that addition and subtraction later, that just keeps it compact, 1.92, there's that one. The sample standard deviation was the 16.44, and then I'm going to do the square root of 100, and that's just going to be 10. So I do this calculation, this times this, divided by 10, or this, parentheses, this divided by that. Okay, but that should come out to be 3.27. I recommend and implore you to go and work with your calculator so that you're getting these values and you're knowing the problems of, any problems that come up with the calculator, and if do you need to insert parentheses around here, or ever how you need to do it, but you need to multiply, divide. Okay. So here is my point estimate plus or minus my margin of error, and this is my X bar that I use for that, and then that is my margin of error calculation, all of that. So my lower bound, I take 37.51, I subtract 3.27, I get the 3424. Here's my interval notation from math. Get rid of that thing. And the upper bound is 37.51 plus 3.27. I get a 40.78. So that's just the little open interval that you would write in math for open intervals notations. And that's equivalent to the 34.24. I'm writing mu here. Notice that X bar is right in the middle. Okay, I know what X bar is. The mean, the population mean, I do not know. And this is where it could be anywhere based on this 95% confidence. It could be anywhere between 34.24 and 40.78. And here's the statement that I said later on we're going to add. We are 95% confident, so we always do this little add the confidence in there because this depends on the confidence level. We are 90% confident that the mean amount spent on Halloween costumes for all U.S. adults, now we're talking about the population, is between 34.24 and 40.78. Okay, so that's building a population mean confidence interval based on a point estimate X bar, and then the margin of error where sigma is not known. T alpha over 2 because sigma is not known, the population standard deviation is not known, and then S, since we don't know what sigma is, we've got to use the S. This opens this up a little bit wider so that it gives us a more of an error, a little wider confidence interval because it's just not as exact. S could change as well as the X bar depending on the sample. Excuse me. So the next one that we're going to get into is a confidence interval, same type of thing, but this time it's for the population proportion. So I've got a population out here and some proportion, P, we're concerned with, but we don't know what it is. So I'm going to put a little question mark up here. So I go grab a sample, and in here, I'm going to call that proportion of what we're concerned with P hat. It could be the percentage of people that like Mountain Dew, okay? But what we're going to do is take that P hat, remember this is our point estimate, and for the population proportion, P, I'm starting with my P hat, my sample proportion, and then I'm going to go P hat plus the margin of error, P hat minus the margin of error. Okay, and that's what this thing summarizes. That's what that is. Okay, I'm going to take P hat, and this is going to be my margin of error formula. Here's my point estimate plus or minus Z alpha over 2. We're back to the standard normal table. And then P hat, 1 minus P hat divided by N. Okay, and take the square root of all of that. Okay, so let's kind of look at one and do a calculation based on population proportion, confidence interval. So in a random sample of 50 New York City residents, 72% stated they are optimistic about the future. Random sample. That sounds like N is equal to 50. This sounds like 72%. That sounds like the P hat because that is just of that sample. Construct a 90% confidence interval for the proportion of residents who are optimistic about the future. Okay, so this builds us this. We're not going to spend much time on here. We're going to do that in class. But we're going to take this and say there's an alpha. So alpha is basically 1 minus the confidence. So 1 minus 0.90, the 90%, that's 0.10, and alpha over 2 is the 0.10 over 2, 0.05. So this is the Z-score for an area of 0.05. And if you go look at your table and find 0.05 in here, or do the inverse normal, you're going to find 1.645. That's where that is from. That tells you the alpha over 2. Okay, so let's continue. Here was my p hat again. What was my p hat? My p hat was 0.72. Let me write this over here. P hat was 0.72. This is all we need to know to get everything that we're going to build from this point. 0.72, we've got the critical value, z alpha over 2. This is the critical value. And then p hat, 0.72, 1 minus p hat. This is also called q hat sometimes. P hat, q hat, the other side. And then divided by 50. So we do all of this calculation first. If you're doing it with calculator and you need to put a parentheses all around this so that it says do all of this first. So it's going to do this in here first, orders of operation. It's going to do that 0.28 times 0.72, and then it's going to do the division, the multiplication, then division, and then it's going to do the square root. So this piece should be here. Make sure you get this after you take the square root, and then the 1.645 after that. So all of this number, so this piece, all of that, the margin of error is 0.104. So then it tells us to do the plus or minus for my left boundary and my upper boundary. Okay. So 0.72 minus the 0.104, 0.616. And the upper bound is 0.72 plus 0.104. I add it, 0.824. That's the open interval that you would use in mathematics. And then we like to do the inequality corresponding to that. And that's this statement here. We're going to learn how to write that in just a few minutes. Okay. So notice that this really should not be p hat. This should be p. The true proportion, the population proportion, is between 0.616 and 0.824. We know what p hat is. P hat was the 0.72. That was the sample. Okay. Okay, so we're 95% confident that the proportion of residents who are optimistic about the future is between 0.616 and 0.824. Proportion of residents, so here is 0.616 again, less than P, the population of all residents, and then 0.824. Not P hat, again, P hat is 0.72. Okay. So here is just getting you started. Write an interval. You know, naturally you're going to do the plus or minus, the 1 minus, and then less than x. And it says here, we're not saying whether this is the mean or something else, certainly not the proportion, but it could be some other thing. And it's just saying, write this as something x, something here. So the lower bound and then the upper bound is what that's for. Here you're actually going to have to calculate it, construct a 90% confidence interval for the mean. And then I'm going to look around here and say, with a standard deviation, does it say anything about the population standard deviation? No. If it's given, use it and use the z-table, but not. And we're going to use the t, the student's t. So I think this is enough to get you started. And here I just want you to spend a few seconds on this one. Write each confidence interval. This is the confidence interval. This is a t interval, and this is a z interval. Okay, it doesn't really matter. It's just letting you know that you did this with a proportion, and here was the p hat, and here was a t interval, x bar. Okay, x bar, the sample was in here, but you needed a t because you didn't know what the population standard deviation was. Okay, so there's the interval. Write it in terms of that. Mu for this one. P for this one, not p hat. Again, that's the sample. Okay, write the numbers from that interval. Okay, so I hope that you found that helpful, and we'll see you next on the next worksheet.